I'd like to start by expressing thanks to Pierre-Jean Nachet and the others who organized this symposium. It's particularly timely because at this period of great social and political uncertainty in the United States and in Europe, it's good to recall the qualities of Kassler, the qualities of personal integrity and of devotion to the truth and of political courage. So that is really thoughts in the background when I call Kassler's world as luminous. The point I was making is that we're at a period of social and political unease in the United States and in Europe. And at times like these, Kassler's personal qualities of integrity and courage are particularly valuable to recollect. So I'm very pleased that this symposium is taking here now and honored to be asked to speak about Kastler. Now, I knew him only very briefly. So in a sense, it's presumptuous for me to talk about him because there's many people here who know him very, very well and are much better qualified. However, the brief meetings that I did have had a lasting impact on me, and I'd like to share that with you. So here is another picture of Kassler. This was the one used in his Nobel Prize presentation, as recorded. And he has, I like it very much. He has a wonderful face. It is clearly someone who is introspective, rather welcoming, a little bit perhaps curious or amused. In any case, he made a very strong impression when you met him, and I think this face sort of reflects that. So I'm going to talk, the two parts to my talk. I'm not going to talk about the most important thing, his scientific contributions. His work was transformative. All of the talks you're going to hear this morning have roots which can be traced back to Kassler, and major areas of contemporary atomic and quantum physics carry the trace of Kassler's original discoveries. So being transformative, it's enormous. I don't want to talk about that. I want to talk about some other aspects of Kassler. So the first part is a little personal tale about the kindness of Alfred Kastler. This is a short story with a long introduction, and it goes back to the time that I met him when we visited here in the spring of 1968. I came to ENS with my family, with my wife Beatrice and our 3 children, and we arrived around the latter part of April and stayed for about a month. And we were given a marvelous welcome here that Jean Brossel couldn't have been kinder to us. He arranged housing for us at Bure-sur-Yvette, and I came to the lab every day. And that visit actually had some important scientific consequences for me. I met Marianne Bouchiat, and she told me about the work that she was doing understanding the relaxation, nuclear relaxation in alkali atoms by Nobel gases. And she and her husband Claude had worked out a theory for how this occurred. And it was a beautiful theory, how the atom and the 2 atoms could come together and form sort of quasi-molecules. They would circle around each other for a long, long time, during which the relaxation took place, and then they'd kind of unwind and leave. And these ideas were so beautiful, I thought about them more when I got back to MIT, and we started experiments trying to make these alkali rare gas complexes and did molecular beam magnetic resonance spectroscopy on them. Now, that had some long-term consequences too, because David Pritchard was my postdoc at the time, and he worked with me on this, and he went on to make studies of energy transfer of excited atoms and molecular processes, which turned into a major theme for his early work. So a lot emerged from this rather brief visit here. But what I want to talk about are some other events which took place. Now, these took place half a century ago, so I may not have all the details absolutely correct. Some people here may not have been born then. There may be some here whose parents weren't born then, so this is rather ancient history. But those who were here will certainly remember about it, because there were certain disturbances that May. So it's a bit of a fairy tale. Once upon a time, a long, long ago, in the spring of 1966.
No, 68.
68, you're right. Thank you, Beatrice. I came, and the family came. As I was coming in, Beatrice went with children into Paris to see the sights. And one day she came back and said we had to come back early because of the tear gas. That seemed unusual. And it turns out that there were unusual events taking place all around us, and I had been totally unaware of them. There was what we call disorderly behavior. And it had started much earlier. It didn't make the American newspapers, but at the university in Nanterre in November of 1965, there was a student protest. Now, student protests take place in universities quite regularly all the time, and they can be rather healthy. But this one grew. The protest, as far as I can understand it, is that the Ministry of Education rather arbitrarily imposed some rules for the students. And the students objected to it. And I think the major objection was they were compelled to go to class. Now, you wouldn't think that's normally too prohibitive, but in fact it is, because students don't like to be told they have to do anything. In any case, the discontent grew. Apparently, the university had been rather neglected. The faculty wasn't really it wasn't there much of the time, and it was a rather depressed place. So they boycotted the classes. Some of the faculty joined in. On the following days, groups formed with differing signals. The university was actually closed down for a little bit. Things continued into January. The students sat in the dean's office. Then there was a big mistake made. The police were called. As soon as you call the police in, that really escalates things and makes them, in a sense, irreversible. These protests continued through March, when they occupied the university and got into big political fights. There were factions among the students. Some were really for reforming the universities. Others felt that you had to reform all of society. Political action committees were formed. So on May 2nd, the dean just closed the university totally, which is a mistake, because if the students can't go to class, they go somewhere. In this case, they all came over to Paris, gathered around the Sorbonne, and there were big demonstrations there. On the 3rd, there was a massive meeting held in the courtyard. The Sorbonne was shut, evidently for the first time in its 1,000-year, 800, 700-year history. The police were called, the students were surrounded, and gently escorted out by the police for their own safety. They were escorted out, and they were escorted out into wagons where they were arrested, which seemed like a dirty deal to them. So that enraged the students even more. Shortly afterwards, the CRS barricaded the Sorbonne. We saw that because we had walked down Rue Saint-Jacques and saw this wall of shields with policemen with helmets and batons, which is a rather formidable wall to go by. There were riots. Many students were injured, and I suspect quite a few police were injured too. On that day, in the middle of the night, Kastler and Jacques Monod attempted to reconcile the rector and strikers. They tried to be conciliators, but they got nowhere. They tried to contact de Gaulle, and de Gaulle refused to talk with them, but they tried. So the following day, things got serious. The students tore up the pavements, took the paving stones, which turned out to be very nice missiles, and there were real fights. That Friday evening, Kessler and Monod were interviewed on TV. They were trying to act as peacemakers, but the government censored the talks, and apparently they were never broadcast. The next day, the newspapers had this headline: Latin Quarter turned into battlefield, police launch assault on barricades, hundreds wounded and arrested, cars burned, apartments occupied, Parisian people support general strike on Monday. I got these details from a book called When Poets Ruled the Streets. I'm not sure it's a reliable book, but I think all these events did take place. On Sunday, we had been invited to go out to the Kasslers to have tea at Bure-sur-Yvette, where they lived. And we called to say that we understood the situation. This would be a terrible time to visit, so let's postpone it. But Madame Kastler said, no, 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 no. My husband and I want you to come. You must come this afternoon. Well, that morning, Kastler headed off a confrontation in Paris by getting in front of a student procession and leading it away from the police. And that afternoon, he rushed out to Bure-sur-Yvette, and we had tea. So the event I want to talk about is Tea with the Kasslers. After our tea, Kastler rushed back to Paris to resume his peacemaking efforts. Now, when we went to tea, Kastler was particularly enchanted by our 4-year-old daughter, Sophie, perhaps partly because his granddaughter's name was Sophie. And he asked her about how she was doing there. Was she enjoying France? And she said, well, sort of. And so he probed further, and he said he found out that she was sad. She was sad because she couldn't have a pet. He said, my parents won't let me have a dog or a cat or a rabbit or a mouse. And he said, do you think they would let you have an escargot, a snail? And she said, oh, yes. So we took her by the hand, and we went for a walk in the woods that afternoon. And during that walk, Kastler found an escargot. He collected it for Sophie. He made a little bed for the escargot, a little box with grass in it. And we went home. And Sophie was very happy with her snail, which lasted all of several days. But at the end of tea, he went back to Paris and continued fighting the mob. Now, this episode of someone stopping in the middle of all this mayhem to pay attention to a little girl to make sure that she was happy has stuck in my mind as what human behavior at its very best, the nicest thing that one could possibly do. He was a role model. And I've never forgotten that episode. I think Sophie remembers it also. Beatrice certainly does. It turns out this is not atypical for Kastler. There are huge numbers of episodes of his kindness to others. And that's part of his legacy. You'll probably hear more about some of these episodes during the course of the day or later. But that's the one episode which has always stuck with me. And whenever I think of Kastler, I think of that afternoon and that snail. Now, I would like to talk a little bit about the science of Alfred Kastler. What I can do is add a few details to his early career because they took place at MIT through Jean Brossel's collaboration or work under Francis Bitter. Bitter and and Kastler became interested in optical excitations of atoms at roughly the same times and had somewhat parallel thoughts, but they were very different people with very different backgrounds. So let me talk about them. This took place between about 1950 and 1960. Here's the picture of Jean Brossel, which we've already seen, but I like it very much because it's the Brossel that I knew, which was a very happy and very enthusiastic Brossel. Now, some of his letters to Bitter were kind of pessimistic. Oh, once again, I haven't been able to do the work I wanted to do, or I'm sorry it's taken so long. At some point, he said, well, I am a pessimist, but I only saw the optimistic side of Brossel. This is Francis Bitter. Notice he was born the same year as Kastler. He graduated from the University of, well, not Chicago. He went to Chicago, took a year off, then went to Columbia and finished up there in 1924. And then he was a graduate at Columbia from 1924 to 28. Then he went on to work at the Westinghouse laboratories. He was working on magnetism. He spent a year at Cambridge working with Kapitsa. And at Cambridge, he became very interested. And Kapitsa was an expert in making very high magnetic fields, but these were pulsed fields. If you tried to keep them on, the apparatus would burn up. So all the experiments were pulsed experiments. Bitter became concerned with the idea of trying to make a continuous high magnetic field. And in fact, he's famous for having been able to do that. He invented a configuration called the Bitter magnet, in which you get the maximum amount of power into a small region and the maximum amount of heat out at the same time. And Bitter magnets are still often used frequently in connection with superconducting magnets. But so his life was really devoted to magnetic fields and the study of magnetism. He joined the MIT faculty in 1934. Later on, his magnetic research grew into a national magnet laboratory, which flourished at MIT for about 20 years and is now located in the University of Florida. His background was obviously very different from Kastler's. In particular, Bitter was not an expert in quantum mechanics, but he needed to use it. For measuring the high magnetic fields, nothing could beat the Zeeman effect in spectroscopy. So he was used to working on that, and that got him involved with some of these ideas on double resonance. So the collaboration began in 1950. Kastler sent Bitter Brossel, and there was a letter from Kastler to Bitter. There is the letter itself. These have all been preserved in the MIT archives. Bitter kept all the correspondence. He was very highly organized. And it said, "Dear Professor Bitter, this is from Kastler. Thank you for your interesting reprints, and I have just received your beautiful book, Nuclear Physics. I thank you heartily and look forward to bringing them along during the summer vacation when I will have tranquility for reading them. Jean Brossel is pursuing his research with me, and I know how happy he would be to work under your direction and to take advantage of the excellent equipment in your laboratories. If he could work with you, I am sure he would achieve excellent results and return with his doctoral thesis achieved." That last sentence was exactly what happened. He did get excellent results with Bitter and did create all the material for his doctoral thesis. Bitter sent Kastler a formal invitation so that Kastler could apply to the Fulbright Committee and to others to get a travel grant. He goes on, "It will not be possible to construct newer apparatus for your use. I'm confident that existing apparatus can be made available or that a joint research project could be arranged." So from the beginning, the idea was that Kastler was going to be going to MIT also to work with Brossel and Bitter. That July, "Thank you for your letter of introduction. I have submitted to the Ambassador of the United States and for your effort to obtain a Fulbright grant for my trip to the United States next year." So Kastler applied for a visa to the United States. I also thank you for the friendly words in that letter. I look forward to meeting you personally at MIT next year, and my colleague Rocard and myself will be happy to greet you in France in the autumn of 1951. It was a warm and happy relationship from the beginning. That December, thank you for sending your paper on theoretical part of the double resonance experiment. I am studying it and hope to write shortly to Bruxelles a letter describing some aspects of the questions. Some of Bitter's ideas were wrong. As Norman Ramsey explained to me once, a fundamental problem was he thought that you would be able to pump angular momentum into a system using magnetic resonance. And of course, in magnetic resonance, you pump it in and you pump it out. So that part of it didn't work. And I think there were some other problems with it, but his basic idea was perfectly sound. His idea was to combine radio frequency spectroscopy with optical spectroscopy, using polarized light to get a particular fluorescent pattern from the atoms, and then changing that pattern by causing microwave transitions in either the excited state or the ground states. That was what double resonance was about. It's a cousin to optical pumping, but it's quite a different goal. He talks about, Kastler talks about trying to do some optical pumping in a beam, and he hopes to have publisher results. The question, how did Bitter and Kastler get to know each other? Perhaps some people here know this. I didn't. I was always curious about this, but there was a comment there. Last week, we had the pleasure to see Professor Robbie visiting the laboratory. So Robbie was here. It turns out that Robbie knew Bitter very well. In fact, Bitter unfortunately died in 1967, but Robbie wrote the obituary, and it says, Bitter and I were graduate students at Columbia during the exciting period 1925 to 28, when the world of physics was reborn with the invention of quantum mechanics. It was a wonderful time to be a graduate student, and a lifetime before one for research and study and the exciting task of remaking the old physics and bringing on the new. One somehow pities those who were born too late or too early to share the excitement of those revolutionary days. It's a very nice thought. We were all, I think, born too late for that, but Robbie's exuberance really shows through. The question is, though, they were contemporaries at the same time, but did they know each other? He goes on and says, Bitter and I were graduate students of Columbia during the exciting period, 25 to 28. We both did our dissertations with Professor A.P. Willis, whose field was magnetism. So I'm sure that's where the bridge came, that Kastler and Bitter learned about each other because Robbie put them in touch. Well, that January, Kastler rather, made up an itinerary, a plan for visiting the United States. He was going to leave Paris May 20th, go to Washington for about a month. At the end of the summer, he would go to the American Chemical Society meeting and then visit Chicago, Columbia, Ann Arbor, and Canada, and return the 15th of October. And the summer, he would be 3 months, June through August, working with Bruxelles. So in a sense, it was a scientific grand tour that they had planned. There was an interesting postscript to this letter, which was just added. There it is. It's a little scheme for doing isotope separation by scattering, making use of the differential scattering properties because of the different masses. Well, from Kastler to Bitter in that March, I have assembled with a pupil the apparatus to illuminate a beam of sodium atoms by circularly polarized light to see how the asymmetry in the M states of this ground state can be driven by optical pumping. I hope to have the first results before leaving Paris. So the earliest work on optical pumping was atomic beams work. It became a wonderful surprise later when it turned out you don't need atomic beams, that the nuclear polarization is very well maintained in cells in spite of collisions with the walls or with gases. There was to be a meeting of the American Physical Society in Schenectady, New York in June. And Carl Darrow, who was the secretary of the American Physical Society, wrote a letter to Bitter. Bitter had been invited to give a talk at the APS meeting in June. This is the formal expression of the invitation which you have just received orally from Van Vleck. Van Vleck, well, he later got the Nobel Prize for his work on susceptibility, but he was the vice president of the APS. To quote from a letter that he wrote to me before the New York meeting, you and your group are doing some nice work in the detection of the intervals in the fine structures of excited states by means of experiments made on the depolarization of light with a simultaneous microwave field, which induces transitions in the excited state. It's a very precise explanation of what went on. Darrow had an interesting career. He had been hired by Bell Laboratories not to do research, but to explain all the contemporary events to everyone else at Bell. So Darrow was an expert at exposition. This program of research was, I believe, undertaken in connection with a French physicist, Kassler, who will visit the United States sometime next summer. And the question was, they wanted Kassler to speak also. The program had been filled. The arrangement was that Kassler and Bitter would share the talk. In April, Bitter wrote to Carl Darrow, "Thank you for the invitation to give an invited paper on the Schenectady meeting. As a title, I propose optical and radio frequency double resonance. I'm writing Kastler outlining what I propose to say and suggesting that his paper be placed ahead of mine and contain introductory remarks. You might arrange this order unless you hear from me." So Bitter was, in a sense, stepping aside. This is a new field, but he was stepping aside to ask Kassler to take the initiative in opening the paper. So this is one other bit of evidence that I have that this really was a very warm collaboration. Time was going on. The plan was to have left by May 21st. On this 22nd, Bitter wrote, "Not having heard from you for some time, I'm writing to ask whether there is anything that I can do to further your plans to visit us this summer. Professor Van Vleck also wishes me to say that he would be happy to do anything he can to expedite matters." In other words, to try to shake the bureaucracy loose. But on May 21st, the US Embassy sent a letter to Alfred Kastler. "You are hereby advised that you have been found inadmissible into the United States under the Act of October 16, 1918, as amended, which relates to membership or affiliation with certain totalitarian organizations." A typical, rather fascistic government, certain organizations, they don't say exactly what, they just denied it. Kassler wrote very shortly to Bitter, "My impression that it would be practically impossible for me to get the visa has been confirmed since by the letter of May 21st, received from the American Embassy. Do not conclude from the text of this letter that I am affiliated with the Communist Party. The fact is that I am a member of the Association of Scientific Workers, organized in France in 1945 on the model of the British Association. As actually Professor Joliot has been elected president of the International Federation of this organization, it is classified as an organization of communist tendency. Perhaps have I realized only in the last days that the acceptance of an American grant would imply my personal agreement to the actual politics of the US government in Europe, what in my conscience actually I may not give, especially as regards the rearmament of Germany." Well, I didn't know that the rearmament of Germany was just on at that time, but Kassler did. And so he was quite reconciled. He had expected to be rejected, but in a sense kind of relieved, because he did not want to be in a position of having to endorse the political actions that he did not agree with. So this is just an example of of high principle of consciousness. And I'd better be a little bit conscious of the time right now. So then he says, enough on politics, I will speak of physics now. And he goes on, and I thank you to include at the New York meeting points that I had intended to cover. Would you please remember the principle of optical pumping? I think this is a new term, he puts it in quotes. Unfortunately, the experiment on sodium atomic beams illuminated by strictly polarized D light is not at this time at the state to give experimental results. Perhaps will you have some time enough to mention the principle of optical detection of paramagnetic resonance in crystals by some measurement of the Faraday effect? And they had done some experiments on that. Now, most of the correspondence that has been stored is correspondent between Brossel and Bitter. Bitter's letters are always rather brief and obviously dictated. Brossel wrote voluminous notes to Bitter. Here, you will find enclosed herewith the results of the computation written down, I hope, in a usable form. In a separate sheet, you will find a comment about each table and about its meanings and about the way it was obtained. The notation is coherent throughout. I have checked the results as well as I could and hope that I left no error, but it is unlikely none squeezed through. The data are complete, sigma as well as pi excitation. And if you want the report to contain only pi excitations, it should be easy to sort them out. So that's sort of the first page, and there are many more which follow with diagrams and such in it. Now, there was a letter, I think it shortly followed the earlier ones, but I don't have the date on it. It's to report briefly on my work of the last 10 days to bring you up to date on the significant advances. And that was his work of the last 10 days, which came him up to quite a few manuscript pages. So Brossel was really highly productive. In looking through his letters, one thing which strikes me, nothing is crossed out. Everything is clear. It was a model of how to write a paper. When I write a paper, it's mostly things crossed out, and gradually something emerges from it. But Brossel just wrote it as it is, and there was never any questions of mistakes being raised afterwards. Then on November 1951, I have been thinking about the matter. This is a letter from Brossel, from Bitter rather, and I'm reading it because it'll strike a resonance with some people. I've been thinking about the matter of thermal relaxation time in the ground state, and it seems to me that I have been too hasty to conclude that the relaxation time was very long compared to a second. Just because the nuclear resonance experiments in diamagnetic gases at atmospheres of pressure or more indicate a long relaxation times. It may be that the magnetic fields in the atomic neighborhood of a quartz wall fluctuates much as though it contained paramagnetic atoms, and that essentially all wall collisions produce reorientation of the mercury nuclei. If this is the case, the experiment should be tried over again, not only with brighter light source, but with the addition of some gas like helium to the vapor in the resonance lamp. I think I shall also set up to do this. So for people who are working in the early days of optical pumping, these questions are very familiar. Okay, in October, Brossel wrote to Bitter a letter, and it contained this little diagram up there. That's a diagram of an atomic beam going through a region of light polarized one direction, and then light in another direction to analyze the populations of the atoms. And that's where you put on the double resonance. Well, actually, this wasn't to put on the double resonance. This was where one wants to see whether the polarization of the ground states of the atoms, whether the M states can be redistributed. So this is the granddaddy of optical pumping experiments. It was a beams experiment, but it was to show that principle. Late 52, a 9-page manuscript on double resonance, including, well, those 2 pages there. All this work that Brossel did was contained in this paper by Brossel and Bitter. But from having looked through the manuscripts, it was all written by Brossel. This isn't to dismiss Bitter's role. He made it all possible, and he collaborated. But the actual writing was done by Brossel. He was the ideal graduate student. He did the experiment, worked out the theory, wrote the paper. Okay. Well, that's the end of the correspondence. There is more correspondence, but that gives a sample of what was going on. But this is just one aspect of what I call the luminous world of Alfred Kastler. For instance, the poetry of Alfred Kastler. Poetry is lustrous language. It's language taken to the aesthetic extreme. Poets think deeply. They're good poets, and I'm sure that Kastler thought deeply, and he had this inner life, which was very important to him. And that's one aspect of his personality which is very valuable. It's very difficult to maintain an inner life these days. There's such excellent communication, we're not given a moment for thought. But Kastler did have an inner life, and he expressed it. Unfortunately, I have not read his poetry myself. If someone has and can talk about it, I would very much like to listen. But just the fact that poetry was important to him tells me a lot about him. And finally, the humanity of Alfred Kastler. We've seen it at the personal level, where it's terribly important. We've also seen his taking principles against the government which acts unwisely in his view. He had a world view. He was particularly a world European view. He was an internationalist. He was a lofty thinker. He was an inspiration for us all. I feel very lucky to have met Kassler even briefly and to know about him. And it's one of the things which makes me feel proud to be a physicist, that there are people like Alfred Kastler who share our profession and show us the way. Thank you.
Well, thank you, Dan, for that very moving and illuminating talk. We have time for some questions, and it will surprise no one that I'm going to ask the first question. If I've understood correctly, Brossel went to Bitter's lab and then came back and did a great deal of the work that ended up in that paper while he was back in Paris.
Yes, he continued. There are letters from Paris,
Yeah.
from Brossel to Bitter. Yeah.
And that work was done in Kastler's lab, and Kastler was constantly in touch with that work, if I've understood what you said correctly.
I don't think Kastler was involved in that double resonance paper. Undoubtedly, I mean, the ideas were so similar and such. I'm sure they were in very close correspondence on that.
Yeah.
But the double resonance was rather kept separate from optical pumping.
Yeah. Well, I guess what I was thinking was that today, it seems like it would have been pretty usual for the senior professor like Kassler to have signed the paper along with his student Brossel, but that Kassler didn't do that.
That's correct. He could have. He was in constant comment with Brossel. And it was sort of an awkward situation where some of Bitter's ideas weren't correct. And, but here, Brossel had gone to work with Bitter. But somehow they managed to work their way through these difficulties very tactfully, because the relationship continued very warm. But the letter does not, the paper does not include Kassler.
Yeah, and, well, I don't know. To me, that indicates that Kassler had a higher standard of authorship than is common today.
Well, he was uncommonly high in nearly every regard, yes. Yeah, no, he was, you know, a deep, conscientious person.
Yeah.
I think that a part of the confusion at the beginning of the 1950s was between the double resonance and the outer Towns effect. I think that at some point Bitter had the idea that by applying a radio frequency resonance between Zeeman states, they would cancel the Zeeman effect, which is not the case and which happens in a different perspective in the case of the outer Towns effect. And so this was part of the confusion, I think.
Yes, well, at that April APS meeting, there was a little note about double resonance, but already by that point, Price in England had written to Bitter to explain the error in his thinking on that. And the little abstract refers to Kassler's work, but doesn't refer to the Price's corrections of Bitter's work. There's a letter from Bitter to Sam Goudsmit, who published the physical review where these abstracts were. He said, he complained, you dropped that reference, which I had in there. And Goudsmit wrote back in some embarrassment. He said, yes, that got dropped by the typesetters who just didn't leave enough space, but he published a correction. So, yes, there were errors. Or as one says today, errors were made.
So while we perhaps continue with the questions, maybe Tillman could come up and hook your computer up, and are there more questions while we're making the changeover? I'd like to ask for maybe a little bit more clarification about what it was that Kastler meant by signaling his acceptance of U.S. policy by accepting a grant. I didn't quite catch that,
well,
that feature.
He just felt that if the country wasn't conducting itself properly, he did not want to accept anything from them.
And that was the Fulbright was that he was referring to in that case?
No, there was some sort of other U.S. supported U.S. supported. We can look at it exactly, but there was a full. They applied for Fulbright and a grant from some U.S. agency.
Oh, I see. So an additional grant to support research in France, or
to support foreign visitors coming to the United States.
Okay. Yeah, and So yes, today I don't think that most of the people who accept support from the U.S. government are in agreement with all the policies of the of the U.S. government.
Some of us have no choice.
but Kastler had a higher standard. So thank you very much, Dan. That was lovely.
Okay.